Hello everyone. So in this video we are going to understand about the Newton Raphson method. So in the previous video we have discussed about the bisection method, regular falsi, secant, iteration method. So if you have not seen those videos, you can check those videos and you can find the link of those videos in the description below. So Newton Raphson method also comes in the category of all those four methods. Like those four methods find the roots of a algebraic and transcendental equation. So Newton Raphson method also do the same thing, but it has some differences from the previous methods. So in this video, we will see that how it differs from the previous methods, and we will also see a working example where we will find the roots using this method. And at last, we will see how we can implement this method using a C program. So as I told you, we have discussed all these four methods in our previous videos. So if I talk about the convergence rate of these methods, then bisection method has a linear convergence rate. And regular falsi, secant, iteration, all are having the linear convergence rate. And these are the values which are written against them. So all these are actually linear in their convergence rate. Now just to recall, what does convergence mean? So as you know, these methods give us the approximate root. That is, we will get some root nearby this actual root, this or something like this, right? So all these methods actually give the root for the algebraic and transcendental equation, but some methods give us the same value or the same root in some greater iteration or larger number of iteration, but whereas other method give the same answer in lesser iteration. So for example, your bisection method can give us some root, let's say x equal to 2.76 for a given function in, let's say, 10 iteration, right? But regular falsi can give us the same answer in, let's say, 8 number of iteration. Okay, so when we say a method is getting converged, it means we will get some root nearby the actual root by that method. That means that method is going to give us the answer and it will be something nearby that actual root. But if some method is like diverging, then that means then that method will not give us the root or the approximate root nearby the actual root. Like as we have studied, the secant method is not guaranteed to converge. It may give us the root which are not the actual root or the approximate root for the given function. For example, this is x1 and this is x2, and then we can get the root something out of boundary in the secant method. We can get the root here also. Okay, so this is the meaning of convergence and divergence. Now this Newton Raphson method that we are going to study in this video, it has the convergence rate as quadratic. So as the convergence rate increases, it means we will get the same answer in lesser number of iteration. So by this figure, we can get to know that Newton Raphson method is the fastest method out of all the available method that we have discussed. So it may happen that Newton Raphson method will give us this answer in, let's say, 5 iteration, whereas other methods will give us the same answer in greater number of iteration than the Newton Raphson method. So this is the difference between the other methods and the Newton Raphson method with respect to your convergence rate. So now we will see how we can apply the Newton Raphson method on a given function. That is, what are the general steps to find the roots of a algebraic and transcendental equation. So these are the simple steps for the Newton Raphson method. So let's say we are given a function, let's say f of x equal to 0, right? And now we have to find the roots of this function. Okay, so what Newton Raphson method says, first you have to find the 2 points x1 and x2 such that they satisfy this property. Now you have studied this property in the previous methods also, like bisection, regular falsi. So this property says that the point x1 and x2, when they are put into the function, then we should get the function value of the opposite sign. It may happen that it is negative, it is positive, or it can be it is positive or it can be negative. Okay, so x1 and x2 should satisfy this condition. Now after finding such x1 and x2, what we have to do next step? So in the next step, we have to find a point x0 which will be between the x1 and x2. So it is something like x0 will be belonging to x1 comma x2, including x1 and x2. And how we can find this x0? So to find the x0, we have actually 3 ways. Okay, so what we can do, we can actually take any point between x1 and x2. So for example, x1 is, let's say, 1 and x2 is 3. So we can say x0 can be like something 2.3, or you can say 2.5, anything. So this was a point. Now the another method, let's say we just skip this b point. Let's say the third way, that is this c point, it is saying that you can find this x0 using the midpoint formula. That means you can say x0 will be 1 plus 3. This 1 plus 3 by 2, it will be 2.5. So you can find x0 using this way also. Now this second way, it says that this condition can be used to find the value of x0 using this x1 and x2. So what does it say? So it says that you have to compare the function values at x1 and x2, okay, but you have to just take care of the absolute value only. That is, you do not take care of the sign of these f of x1 and f of x2. So for example, let's say we put this x1 and we got some, let's say, -3, and we then put 2 in this function and we got, let's say, minus of 5, let's say. So what we will do, we will compare just -3 absolute value and -5, okay. So it will be 3 less than 5. So we will compare only the magnitude. Now whichever magnitude is lesser, we will set x0 accordingly. So what we will do, let's say here f of x1 is lesser than this f of x2. So x of naught will be equal to the corresponding x1. So that means we will take this one inside this x0. So x0 will be 1. Similarly, if this condition is false, then we will say x0 will be initialized by x2. So these are the three ways by which we can initialize our x0. So now we have found the x1 and x2, and we have found the x0 also. Now third step says that you can now start finding the roots of the given function. So what does it say? It says you can find the root like x1, it will be the first root, then second root x2, then third root, and so on. Okay. So here, this is the general formula for the Newton Raphson method. So for example, we have x0, okay. Now we are finding x1, okay. So this n is saying that this is the iteration that you are finding. So let's say we say n equal to 0, okay. So let's say if we put n equal to 0 in this formula, then we can get x1, and this formula will reduces to this f of x0 upon f dash x0, okay. So this dash means the differentiation of the function f of x, okay. So this way we will find the x1. To find the x2, what we will do? So how we can find the x2? If we put n equal to 1 in this formula. So putting n equal to 1, we will get x1 minus f of x1 upon f dash x1. So we can see that when we are finding the x2, we are actually taking the help of x1, right? So similarly, if you find x3, then what will be the formula? So x3 will be x2 minus f of x2 upon f dash x2. That means to find the x3, we are taking the help of this x2, which was found in the previous iteration, okay. So similarly, the next iteration will take the help of this x3, and so on. We will keep on repeating, and we will be finding the next roots. And what is the stopping condition for this Newton Raphson method? So we can stop either when the maximum iteration are reached. Suppose we say that we have to do these all steps, that is x1 and x2, x3, x4. We have to find these all roots till, let's say, 5 iteration, okay. So that means we will just find the x5, and after that we will stop, and we will say the value that we got by x5, it will be our final root. And we can also stop when the difference between the current and the previous root is less than our tolerance. So tolerance means absolute error. So let's say in some iteration x3 you got root as 1.578, okay, and in x4 you got root as 1.5 5 7, let's say 7. Okay, so and your question is saying that you have to match till 2 correct decimal places. That means after decimal places 2 points should be matching. So here this is 5 7 and this is 5 7. That means in the fourth iteration you are going to be stopped because the x3 and x4 they are matching till 2 correct decimal places. Then you will say x4 is your final root. Okay, so this way you can stop, and this tolerance is showing that the difference between this x3 and x4 should be lesser than some absolute error, which can be like given by user also. Okay, so for 2 decimal places it will like 0.01 that we have discussed in our previous methods also. So these are the simple steps to apply the Newton Raphson method on a given function. So I hope you have got an overview that how these steps can be applied on the given equation. So let's see a working example and get a good overview that how we can implement this Newton Raphson method on a given function. So here is our question. We have to find the root of this given function or the equation x cube minus 3x minus 5 equal to 0 till 4 correct decimal places. That means we have to find the roots till the point where after the dot we should get the 4 digits matching between the current and the previous root, right? So let's see how we can implement or how we can apply this method. So firstly, we have to find 2 points x1 and x2, okay, such that this opposite sign condition is true. Okay, so let's put some values and see where we can get this condition satisfied. Let's say if we put 1 in this equation, so it will be this one. Okay, so it will be 5 minus 3 8, and this will be total minus 7. So this is the negative value. Now let's see for the positive value. So if I put 2, then this will be 2 cube minus 3 into 2 minus 5. That means so it will be minus 3. Again a negative value. So let's put some another value. Let's say 3. So this will be 3 multiplied. It will be 13. That means this is a positive value. So this is negative and this is positive. So what we can do, we can take x1 equal to the corresponding this 2 value, and for x2 what we can do, we can take this 3 value. Okay, we can also take x1 as 1 also. Okay, but if we see boundary between 1 and 3, it will be greater than the boundary between 2 and 3. So if we take this boundary, then we will get the same answer in lesser iteration, but in the 1 and 3 boundary we will be getting the answer in the larger number of iteration. Okay, so if we take this answer also, let's say x1 equal to 1, then also we will get the answer but in larger number of iteration. So we are taking this values for our current question. Now the second step is we have to find the value of the x0. Okay, so we can find the value of x0. So we can take any value between 2 and 3 for x0, but we will use this b step to find the value of x0, and we will use the same thing in our program also. So it says that you have to compare the absolute value of these functions, and whichever is lesser we have to initialize x0 using this corresponding x1 or x2. So here if we see for the f of x1, that is f of 2, we have minus 3. So absolute value of minus 3, it will be 3, and absolute value of this 13, that is corresponding to this 3, it will be 13. Okay, so we can see this 3 is lesser than 13. That means x0 will be initialized via x1. And what is this x1? This is 2. This is 2. So x0 will be 2. Okay, so you can also take the value of x0 using this midpoint formula, that is 2 plus 3 by 2, that means 2.5 also. That will also be correct, but it is recommended like, but this will be like good one value. Why? You can see like minus 3 will be something like here, and this 13 will be something like here. So which value is closer to 0? So you can say this value is closer to 0. So corresponding to that value, you should take the value of the x0. Okay, so corresponding to minus 3, we have this 2. So that will be like helping us to find the answer in some lesser iteration. Okay, otherwise this value is also fine. So x0 will be like 2. Now the next step is we have to apply the formula for the Newton Raphson method. Okay, so Now we will find the roots, that is we will be finding x1, x2, x3 and so on. So if we find x1, so we saw x1 was x0 minus f of x0 upon f dash x0. Okay, so here we can see we need the differentiation of the function f of x. Okay, so what we can do, we can find the f of x with its differentiation. So what is the differentiation of this? So it will be 3x square minus 3. Okay, so let's find the value of this thing. So x0 is this 2 and f of x0, that is f of 2. Okay, and this will be f dash 2. So this will be 2 minus, what is the value of f of 2? It is minus 3. Okay, and what is f dash 2? So if we put 2 into this, so it will be 3 into 2 to the power 2, 4 minus 3. So it will be 12 minus 3, it will be 9. This will be 3 1 ja 3, 3 ja 9, 1 upon 3. So it will be 7 by 3. And if you solve this, you will get 2.3333 and so on. So this is my x1. Okay, so similarly, let's find the value of x2. So what will be the value of x2? So it will be x1 minus f of this x2 upon f dash x2. Okay, so this x1 is what we have found here. So x1 is our 2.33 minus of f of 2 point function of this f dash. We have to find the value at this point. Okay, so if you solve this, you will get something like 0.70325 divided by, and the value after solving this differentiation, you will be getting 13.3328, some value nearby it. And after solving this, you will get something value nearby 2.2055. Okay, so we can see that after this decimal place, we are getting 2805, and here it is 333. So these 4 digits and these 4 digits are not matching. That means at x2, we will not stop. We will find the value of x3 also. And we will use this x2 when we are finding the value of x3. So let's find the value of x3. So our x2 that we have got is 2.28055. Okay, so now x3 will be this x2 minus f of x2 divided by f of dash of x2. Okay, so I will directly use the value. So this will be 2.28055. Now if we put this value at x2 and we find the function value at this point, we will get 0.01928. Okay, and then when we will put this x2 into the differentiation, that means inside this, then we will get 12.6027, and after solving this, we will get 2.27902. Okay, so again we can see here we have 2790 and here it is 2805. That means these 4 digits are not matching. So again, we will not step at x3, we will find the value of x4. So now we will find the x4 and we will use this x3. That means x3 minus of f of x3 and differentiation of f of x3. Okay, so again x3 is this, and when we put this value inside our given equation, we will get this answer 1.53 into 10 power minus 5, and upon if we put this 2.27902 inside the differentiation, we will get 12.58175, some value nearby it. So after solving all this, we will get 2.27901. So this is our x4. So here we can see after this dot, we are getting 2790, and in x3, we were getting 2790 after this decimal place. So here x3 and x4, they are matching in their 4 digits. Okay, after the decimal place. So here we can say we have got our matching criteria fulfilled. Okay, so now we can say our x4 equal to 2.27901 is our root for a given function. Okay, and we can stop now. So just to recall, we found the value of x1 and x2 using this condition. So after that, we found the x0 using this approach, that is we compare the absolute value of the functions. Okay, and after that we find the roots. And how did we find the root? We using this formula. Okay, so x1 is getting used in x2, x2 is getting used while we are finding the x3, and so on we are finding till our criteria is fulfilled. So now let's first understand the pseudocode of this Newton Raphson method. And after understanding that code and implementing this into a C program, we will see that how this Newton Raphson method can be understood graphically, why it is giving us answer in lesser number of iteration. So if we see how many functions we will be using in our Newton Raphson method, so one function will be like f of x. Okay, so this function will be for this given equation which is given to us. Okay, and next function we will be using in our pseudocode, it will be one function which is giving us the differentiation of this function. Okay, we will be giving some x value to that function, and it will be telling us that what it will be the value at the differentiated function. Okay, so let's see how. So as we discussed in our previous methods, we have to take the x1 and x2 from the user. Okay, and how many times we want to run this method, that is maximum number of iteration, we have to take from the user. Okay, now after this we have to validate whether our x1 and x2 given by user, they are correct or not, that is they are satisfying our property of the opposite sign or not. So we have validated them inside this while loop. This we have seen in the bisection regular falsy method also. So till the point this condition is true, that means this opposite sign condition is not valid. That means if this condition is true, that means we are getting the f of x1 and f of x2 of the same sign. So we will keep on asking the x1 and x2 from the user. And after we have found the correct x1 and x2, we will come out of this loop. Okay, and after that the next step is we have to find the x0 using these steps that we have discussed in our general steps before also. Okay, using this concept of absolute value. And after that we have to find the roots, that is we will find the x1 and x2 and so on. How many times we have to do this? We have to do this till maximum number of iteration. Okay, so what we can do, we will apply a loop. Okay, and we will first find the value of x. Okay, so this x will be found using this formula. So what we are saying, we have the value of x0. Okay, and we will find the x. Okay, x will be x0 f dash x0 upon f dash. Okay, this is dash and this is simple. So we will use this x0. Okay, so you can say that this is actually x1. Okay, now what is this f and what is this differentiate? So this f is the simple function. Okay, so you can see this will be a float function, and this will have our equation. For example, return, and let's say we have equation x cube minus 3x minus 5. So it will give us the value of the function at the given x point. Okay, so after that we have the differentiate function. So this is like differentiate function. So it will have some float. Okay, and inside that we will have the differentiation of this. So what is the differentiation of this? It is 3x cube minus 3. So here we will be like writing return 3x cube minus 3. Okay, so at given x value we will be getting the value of this function, that is differentiated function. Okay, so after this, let's say we found this x1, or you can say simple x. Now what we have to do, so we can stop at one another condition also. When we have found the difference between the current x and the previous x was x0 and current x is this. So if the difference between them with their absolute value is lesser than our threshold, or you can say tolerance value, then also we will say we will stop and we will say this is our final root and we will return. So here we are matching till 4 correct decimal places, so I have written this value. Okay, but if this condition is not true, okay, then what we will do, so we will come out of this if, and what we have to do now. So now what we want to do, we want to find x2. Okay, so it should happen that we should go up again, and here we should find the value of x, that is new value of x. So new value of x will be like x2, but x2 can be found using this x, or you can say this x1. So here what we want, that here inside x0 we need this x, that is this corresponding x. Okay, so that means here we should write x, so that the current x should go inside x0, and this x0 can be used here in this formula, or we can say this x1 can be used here in this formula. Okay, so that's why this line is very important. So accordingly we will find the new x2, okay, or you can say new x, and then again we will check whether difference between this x2 and the previous x1. So if we see, let's say the here in the first iteration I equal to 1, the x was, let's say, 5, okay, let's say, and we found this x as 5, and after that x0 was taking this 5. Okay, so that means when in coming into the next iteration, here 5 was getting used, and new x, let's say it come out as 6. So now by this condition we are finding the difference between this 6 and this 5. So this 6 is our current x, and this 5 is our actually x0. That's why we are writing x minus x0. Okay, so the same way we will find the difference. If it is okay, then we will print x return, otherwise we will take this 6 inside x0 and we will repeat the steps again. Now after running this loop till the max number of iteration, we will come out this loop, and we will say that finally we will print the last iteration number x. Okay, the x that we have found in the last iteration, that will be our final root. Okay, so we can print the root either from this way or this way. I think you have understood the pseudocode of this method, because these are very simple steps. Okay, but if you have any query or the comment related to this method, then you can write down into the comment box. I will answer them. So now let's see how we can implement this method into a C program. So here is our C program to implement the Newton Raphson method. So here we can see that we have two functions. One is f function and one is differentiate function. So this f function is implementing our equation, and this differentiate function has the differentiation of this given equation. Okay, so this function will take the some value of x and it will be returning the function value at that x point. Similarly, this differentiate function will be taking some x value and it will be returning the corresponding value. Okay, so inside main function we have scan the maximum number of iteration. Okay, and inside this do while loop we are asking the value of x1 and x2 again and again from the user till our condition is satisfied. So if this condition is true, that means our values are invalid of x1 and x2, we will continue. Otherwise we will say our root will be between x1 and x2 and we have found the correct value of x1 and x2, and we will come out of this do while loop using break. Now after that we have to find the value of x0, okay, using this condition that we have just discussed. Okay, so we can also find the value of x0 using the midpoint formula. Okay, but we have used this equation for our current program. Okay, so after finding x1 and x2, then x0, now we have to find the roots. Okay, so here you can see we have used the loop. Okay, and inside loop we are applying the formula of the Newton Raphson method. Okay, and after that we are checking the absolute value difference between x and x0. If it is lesser than this epsilon, what is this epsilon? This is the, you can say, threshold value or the tolerance value. So we are matching the 4 decimal places, so we have written this thing. Okay, for 3 decimal places matching we can write this thing. Okay, so now when this condition is true, this difference is lesser than this epsilon, we will be printing our final root and we will be stopping. Okay, otherwise we are just printing the intermediate root. Okay, and we are setting this x0 via this current value of x so that it can be used in our next iteration. Okay, so after this for loop is over, we are saying, okay, whatever the value we have got in the last iteration, we are printing that corresponding value of the root or the x. Okay, and after that we are returning. So we have used this minus minus I just to print the last number of iteration, because after we come out of this I loop, it will be like I will be something greater than max iteration. So if max iteration is 7, I will be 8, but we want to print that our iteration 7, we are getting this x answer. So we are decrementing this I by 1. Okay, so this is our complete program, and let's now see, we will run this program and see what is the output. So let's run this program for, let's say, 13 iteration. I'm inserting 2 and 3. Okay, so here you can see that in 4 iteration we are getting the correct value, okay, of the root. So in the 4th iteration we can see our final value is 2.279019, and in the iteration 3 and iteration 4 we are satisfying our matching criteria. So when we solve our question, we have got the same answer in the 4 iteration. Okay, so you can find this code in the video description also, you can check from there also. So I think you have now understood that how we can implement our Newton Raphson method into our C program. Okay, so now we will see that why the Newton Raphson method is faster than other methods. Okay, now we will see how we can derive this value of x. Okay, so let's say we have some function, okay, f of x, and we will see how this Newton Raphson method is actually working graphically. Okay, so this is saying that at some value of x naught we are finding this x. Okay, so let's say we take some value of x naught here, so corresponding to this x naught we have this point. Okay, this is a, so we can say this is x naught comma f of x naught. So what Newton Raphson method says, it says that at this given x naught you have to draw a tangent. Okay, so what is tangent? So we will draw a simple line which will be touching at this point to this given function. So if we draw a line touching this point, we will see this line. So this is a tangent at given this point. Okay, so at here it is cutting this x-axis. So this is your given x, that means this x. Okay, so this is our root. Now you can say that this is your first root x1. Now to find the x2 in graphical method, what we will do? So this method says that you will find this point. Okay, let's say this is B point. Now again at this point you will draw a tangent. So if I draw a tangent, okay, so it will be something like, so it will be like something straight line, and it will be cutting at this point. Okay, so this x is the new root. Okay, so you can say this is new root. So here we can see by drawing a tangent, Newton Raphson method is finding the value of your root or the x closer to this actual root in a very fast manner. Okay, but if we find the same thing using the secant method, in the secant method, if you just recall what we were doing, we were taking 2 points, okay, and we were drawing a point here and then here. Okay, then we were drawing a secant, okay, a chord. Okay, now we took this as the value of x root. Okay, and then we were finding this point, and again we were joining this point. Okay, so this was our new x. So in this way we were finding the root in the secant method. So if we compare this Newton Raphson method in the secant method, we can see that if we draw tangent, then we can get the same answer, or the you can say the root in lesser number of iteration. So this tangent is actually represented using this equation in a mathematical manner. That's why Newton Raphson method is actually finding the roots in lesser number of iteration. Let's see how we can derive this. So here we need the equation of actually tangent. Okay, so what is the general equation of the tangent? So it is actually y minus y1 equal to dy upon d of x, okay, and this x minus x1. So this is the equation of the tangent actually. Now this is at actually some point x1 comma y1. This is the general thing, okay. Now we have to find the equation of tangent at this point. What is this point? x0 comma f of x0. So if we put this x0 comma f of x0 in this equation number 1, okay, so what we will find, y minus f of x0 equal to, so this thing can be written as f dash actually x1. At x1 actually this is the differentiation, so this will be f dash. Now here it was x1 but here it is x0, so this is x0, then x minus x1, okay. Now this tangent was actually cutting this x axis at which point? At this point, at x point. So here coordinate was x comma, here y is 0. So if we put this x comma 0 in this given equation, equation number 2, what we will get? Y is 0 and this will be similar, okay. So this will be same and the value of x is the same x, okay, and this will be x naught. So now we can easily find the value of this given x. So we have found the value of x, so this is our x, okay. So this is the same formula. So in this way we can derive the value of x, and we have understood that how Newton Raphson method was finding the value of this x in the graphical manner also. So I hope you have understood the Newton Raphson method and how it is working on a given function to find the root. You have also understood that how we can implement this using a C program. So if you have any comment, query or suggestion related to this Newton Raphson method, you can write down into the comment box. And if you are new to this channel, please subscribe this channel and press the bell icon for further notification, because I make many other videos on the C programming, interview question, lead code questions, and you can also find the numerical method playlist in the description below. You can check that also. See you in the next video. Till then, goodbye.